sharing slides, and I will introduce myself and we'll get the thing started. We do it early so that we have an on-time technical talk at 6 o'clock. If that makes sense. All right, welcome everybody to Husky Bites. This is a Michigan Tech webinar, and you can join us by multiple means, either Facebook live stream, through the College of Engineering at Michigan Tech, or else through Zoom, which is the easiest place to ask questions and answers. My name is Janet Callahan. I am Dean of the College of Engineering, and I want to thank sponsors, and I'm focusing the people who have given in support of our nano satellite that's called Stratus, who include Eloise, Donald, Susan, Bob, John, and many anonymous donors. I am pleased to report that we are up to 220,000 out of the goal of 250,000 for Stratus. And I'm going to go to the next slide because this shows where you can give if you would like to give. And so we have a link here, which is basically superior ideas /projects/Stratus. And if you missed this talk.
Janet, sorry, you're not sharing your screen yet.
Oh dear. Thank you for telling me that. All right, I'm going to stop for a second. There we go. Share screen. Am I now?
Yes.
All right, thank you. I'm going to go back to the beginning so you can see the first slide. All right, so I'm not going to repeat myself though. So welcome everybody to Husky Bites. And so if you would like to give in support of helping our satellite get to space, this is how to do so. If you missed the talk where we talk about this, I've put a link in there, which is basically through the, there's two ways you can watch this. One way is through Facebook. Click on the videos tab at the top and you should find a link to this talk. And the second way would be to directly follow this link, which is a YouTube link, or if you want to find that, you would go to Michigan Tech Engineer. You would Google Michigan Tech Engineer YouTube, and then you would find this talk on the satellite. So just a few more sentences about Stratus. So Stratus, we are going to get Stratus to space. I am going to ensure this happens by putting the power of the College of Engineering budget behind it. I need to repay that with donor money over time, but I can buy time by putting College of Engineering money behind it. And because it's really important to get this particular light to space. And I want to give a super thanks to everyone who has given so far. And if you would like to give, please give in support of Stratus. If you give $2,000 or more, you can get your name written on something inside the satellite and your name will be in space, which I think is pretty cool. Up next, we're going to have a really delightful talk by Martha Sloan, who is a professor emerita, which means she retired with distinction from the Department of Electrical and Computer Engineering. The co-host will be Dan Furman, who is the chair of the Applied Computing Department in the College of Computing. And if you remember taking a course from Martha, I especially want you to join us, and because it'll be a lot of fun. Well, I met some Husky Bitesers up here in Houghton over the last week. Here are Amy and Rachel, who I met at church, and I didn't know their faces, but they recognized me, and she said, Janet Callahan, and I said, yes, indeed. So it was nice for them to agree to get their photo taken. And then I also had a drop-in visit from two people who are teachers in Pennsylvania, who watch Husky Bites regularly. Their daughter is attending university here, and their daughter has the Alumni Legacy Award, which I wanted to mention to you. So out-of-state students get in-state tuition rates, which is a really big deal. It's worth $20,000, I think, if they are the son or daughter of an alum or the grandson or granddaughter of an alum. So just kind of be aware of that Alumni Legacy Award. It can be pretty powerful if you're out of state. And so they're going to send me a picture. They're watching it now, and they're going to send me a picture of the entire family watching Husky Bites next week. And just as an extra welcome, so those two particular teachers wrote to me about, I want to say about a year and a half ago, saying, we're going to ask our superintendent of our school in Pennsylvania whether this can count for professional education units. And they did ask that person, who said yes. And so what we do is verify their attendance at these Husky Bites, and then they get professional education units, learning something new, and also staying in touch with kind of, their daughter's university. So if you are an educator of any kind and you want to do that, just reach out to your own superintendent. And if you're in the state of Michigan, you can qualify for getting sketches according to what's written on this screen. Happy National Engineers Week 2022. This is E-Week. This was founded in 1951. It is usually celebrated around the time of George Washington's birthday, which is apparently February 22nd. And he was considered to be the first US engineer, which I didn't actually know. And the students of our Engineering Honor Society, Tau Beta Pi, assemble events this week. And so Dr. Yo, you're our first event of the week because you're giving our E-Week seminar. So thank you for being able to do this. And if anybody on campus wants to get some E-Week cake, read more about it in the, oh, all right, I keep on forgetting I have all these slides. So can you tell what you were seeing? What does it look like?
Flying on the
Yeah,
canal.
so this is the view outside my office window, which is over the waterway. And you are seeing parasails with little tiny people at the end of them. And I'm going to zoom in so you can see a little bit better. So can you see, this is a person on a, I believe it to be a snowboard, harnessed to the wind, and he was tacking his way. So the wind's blowing that way, right? He was tacking his way backwards and forwards against the direction of the wind, because I think he had to get back to his car. He's out there with a buddy, and boy, they were having fun, and it looks exhausting. Every now and then they had to sit down and take a rest. So this was right outside my window, Zhanping. Have you ever seen this before?
No, never.
I know, it was pretty cool. All right, so I'm going to stop sharing, and Zhanping, you can start sharing, and I'm going to introduce you now. So it is my pleasure this evening to introduce tonight's speaker, Professor Zhanping Zhao, excuse me. When asked about his hometown, Zhanping, Dr. Yao considers Houghton to be his hometown now, since he's been here almost 17 years. He was born and raised in Northwest China. Dr. Yao earned his PhD from the University of Illinois at Urbana-Champaign, and then I believe has been a faculty member here ever since. And we're going to be learning about his research. And I'm going to, well, one more thing I definitely want to say about Dr. Yao. Dr. Yao is one of our distinguished professors at the university, which is one of our highest honors that we have. And this is taking into account his really strong scholarship and accomplishments across the years relative to research and education. And so with that, I'm going to turn it over to you, Dr. Yao, to also introduce Kobe and to take it from here.
All right, thank you very much, Jeanette. And thank you for all the nice words you're talking about me and as an introduction. And so in a few minutes, I will introduce my assistant, Kobe. So basically what I'm going to talk today is about tire rubbers, basically from the waste tires. And before we do that, I'd like to just start with two polls here. So the first one is, what is the percentage of waste tires goes to landfill in the US? So, and the polls come out, so just feel free to pick whatever answer you like.
Well, and I'm going to read out the choices. So that the choices are A, 5%, B, 15%, C, 50%. And so what percent of waste tires, so we're talking about the tires from your automobiles, what percent of them go to landfills in the USA? All right, and we've got already more than 150 people here, which beats Valentine's Day already, I think. Last week. So it looks like there's a majority vote here. People are chiming in at 50%.
Yeah. All right, that's great. That's a great response. Let's move to our second one, and I'm going to introduce what's the number in my mind.
And while
so
you're doing that,
share results. Okay.
No, you
well,
just hit the red X, the red button at the end, and that'll make it leave
Okay.
your screen. Yeah.
okay, sure. And the next one, next question basically is waste tire as a fuel. So what is the percentage of waste tires that be burned as a fuel? So the answer is 5%, 25%, and it's 37%. So the pose out. So just feel free to pick that one also.
So
Is that-
Sue should be launching a second poll if she has it. Meanwhile, you can think in your head what the answer is. Do you think, so what percent of waste? So this is all around the world. Yeah.
Maybe
Oh,
let
is
me
it
close
still,
this.
is this still in the USA?
Yes, in USA. Yeah, I did not write that one.
Are you launching the poll or is Sue?
I think Sue is.
Okay.
It was up, by some reason things did not.
Let me try it again.
Okay, sure.
Well, I'm going to take my guess here. I'm going to guess 5% because I hope people aren't burning tires. Oh, here we go. We get a chance to. So that was
This is the first one. This is the first poll. Oh, I see. The second one
It
is
doesn't want to
here.
launch this one.
All right,
How's
we're
that?
going to give up on it. We're giving up on the second poll.
Okay, all right, we can give up. Yeah. So
But you can
basically-
take my guess. My guess is 5%.
Okay, well, yeah, I think it's bigger than 5%, but do you think we can go to about 37%?
Really? Oh my gosh.
I don't know. I ask. Let's take a look. Okay, I have an official answer here. Okay, basically, my answer is come from is 2020 data from a U.S. Tire Manufacturers Association. If you take a look at the left-hand side, basically these are all the tires we generate each year, about 4.5 million tons a year. And you can see the tire-derived fuel is about 37%. So basically that has been burned, basically to as a fuel. And land disposed is about 15%. It's not like 50% because it's pretty much almost like illegal if you dump those things in the garbage, I guess, at least not in Houghton. You just cannot really put it in the garbage. You have to pay, was that $5 a piece so that you can recycle it? So you have to pay for that. But my point here is you can see land disposed and the tire derived fuel together, that's already 50%. And there are some other applications, really, for example, like a ground rubber. And of that, really, a total is 4% of the tire rubber is used in asphalt. It's very, very, very small, 5% only. All right, so 4.2%. So I like to see this number increase dramatically. Even, let's say, not 40%, but really I like to see it really much bigger number because that is more valuable in my opinion. So next, what I'm going to show you why I think that way. All right. So today I'm going to talk about use a tire rubber and build the roads. So that's basically what my first thing talking about here is called field experiments and applications. And then we're going to talk about some laboratory research work we're doing here and some modeling effort. And then we're going to talk about education force, workforce development and some of the recognitions we received because of our projects. And then briefly, I will provide some closing comments. Next one I'm going to talking here is about some typical road structures. And you can see every different roads, they have different road structures. You can see US 41 in Berga County. The reason I say in Berga County because of one of my projects is in Berga County. So I just wanted to show you, for example, you have subgrade, on the top you have subbase, which is aggregates, and then on the top 6-inch, with another type of aggregates. Then on the top, we have 3 new layers of asphalt. All right. So this project is basically, we call it reconstruction. So that's the reason everything is pretty new. So asphalt base, 3-inch, and the leveling asphalt, 2-inch, and then on top is a 1.5-inch asphalt. So basically, you can see this is the structure we have in US 41. But if you think about some other major highways, let's say heavy traffic volume roads, that's probably the thickness is much thicker. All right, now let's take a look at County Road 607 in Dickinson County. So this is basically called pretty much called a cross and shape type of project. So basically everything like subgrade, aggregate base, and aggregate base. So all those things are existing roads. You're not going to break down those structures. However, on the top, we have a 7-inch, about 7-inch here. We call the crushed asphalt base because those are old pavements. So basically they are not really good to use. So basically they break down as a base. And then on the top, they have 2 new lifts of newer pavements. So basically one is 2-inch of leveling layer and a 1.5-inch of a surface layer. So make that way. So basically you get a brand new roads. But this road, of course, is you are not going to construct from a very deep. So restart. So basically, of course, this type of construction, normally it costs less money and pretty much you give brand new road. All right, so basically what my point here is, you can see asphalt layer actually in the roads is occupy a lot of, weight there because, one is basically price wise, it's a kind of expensive for all the structures. Asphalt layer is the most expensive part. For a given project, the cost could be 70% of the materials cost or even more. All right, that's basically the general information about the typical road structures. And my next introduction will be how we recycle tires. And so right now we get a lot of older tires. Let's see, this is the facilities I visited. You can see on the left-hand side, you can see so basically this fellow is, roll those old tires and then trying to shred it, right? Shred it. And then over here, so basically they shred it to small pieces. And we are going to process those pieces to finer materials to use. Of course, eventually, like this type of size, of course, is very coarse. All right, you can see it's pretty coarse. And so our material is even smaller. So basically the processing, there are a couple of stages. So basically the first one, basically the tire is shredded and then basically become chips, right? And then we are going to process to get rid of the metals, because in tires, there are a lot of steel metals there. So basically we need to extract those metals because in asphalt road, we don't want to put the metals there. Especially in Houghton here, you can see we use a lot of salt. The salt going to steel, what's going to happen? You get a lot of brown roads or something, But so that's basically not really fun. So next thing we call stage 3. We're going to granulate the chips again and again, and then basically also remove the fibers because there are a lot of nylon fibers inside. Those fibers are not really, we like the rubber. We don't really use the fiber there, even though we have a research project recently starting to deal with those fibers. And then of course we got all those materials ready. You can see the my corner picture here, basically showing the fine particles. Those particles normally the size roughly about the mesh 30. So basically those are good for asphalt applications. All right, so basically that's to give you a really quick introduction about how we really recycle tires. So next one, we are going to put the tires in the rubber to the roads. All right, so my first experiment was in 2015. We did some work at home. So this is a road near us. It's only about 10 or 15 miles away from campus. And you can see this in Kewanee County. The S plant on the left-hand side is Pinot Dolan plant in Hancock. And on the right-hand side, basically this road called Gay Mohawk Road. So basically next to basically connect with US 41. So basically this road basically is taken as our experiment road, but this is a county road. So basically, this is of course after construction, it's the road looks pretty beautiful. And we have our sponsor signs here showing the eagle, the current eagle in that time is called DEQ. You can see we have signs basically showing the test sections. This means the hot asphalt with rubber. And we also have warm asphalt with rubber. So basically there are 4 signs at least on this road of section. Probably the road is about 6 miles stretch. So with that, and our successful project also goes to downstate in Kalamazoo. You can see on the left-hand side here is basically, I have basically a general illustration of asphalt plant. So basically in the past in Kuna County, the project was the rubber was in the asphalt storage tank already. All right, so for this case, we have some more innovations. What we have is we are introducing the rubber from the ground tire rubber bin to the dryer mixer, which is the key component of asphalt plant. So when the rubber meet with asphalt and stones together, when they get ready, they lift up to the silo here. All right, so basically all the trucks, we haul the materials to the job site. And here, of course, on the right-hand side, basically what's happening in the field. You can see, people are gathering here to see what's happening, how really we can introduce rubber into the asphalt plant. You can see the rubber go down and then elevate it up to the dryer and mixer, heat it up, and then meet with asphalt stones together and make the final product. All right, next one, I'm going to show you what the final product look like. Here, basically, you can see this is the final product, being loaded up and then feed it to a paver, and the paver is going to, level it off. You can see, before that, of course, the road is being milled because, we don't want to add more elevations. So basically, we want to really, for example, put about 1/2 inch of asphalt surface. So basically, we remove about 1.5 inch from the existing road because the existing road get a lot of cracks, a lot of issues. We remove that section, we recycle those asphalt. Eventually, with the rubber, with new asphalt together, we come back to the roads. So here is basically this asphalt. There are a lot of rubber inside. Basically, this is the highest rubber content we have played in our research, about 18%. All right, so basically this is a lot. All right, let's move on. I'll show you basically a project we did in Dickinson County. Here in Dickinson County, so basically you can see this one is a project I just mentioned called the crush shape. So basically they finish up the base already, and then basically on top, so basically we have first lift of asphalt about 2 inch, and then we have another 2 inch on the top. You can see on the right hand side, you see the second 1.5 inch is placed. So for this project, of course, the rubber materials being used is about 10% of the asphalt. So basically, decent amount of that. And so basically, the road basically is performing really well after 3 winters. So this is basically the project in Dickinson County. I'm going to show you really one exciting project that we happening last year. This project is basically in Kent County near Grand Rapids. So basically this road, you can see this is a pre-existing conditions. You can see after we close the traffic, and because this road is going to be repaired, so basically after close traffic, we had the picture here. You can see there are a lot of cracks and a lot of really, potholes also. So basically there were, this road, of course, have really heavy traffic. So basically what we did was using rubber asphalt. We only did basically this called a overlay, similar thing. We milled it off about 2 inch on the top layer. So basically milled off. So basically then we just pave another 2 inch back. Of course, compact it, make sure things going well. So basically the density is reaching the desired one we'd like to see. So basically you can see this is 5 lanes, right? So basically after the 5 lanes are done, you can see we have 3 lanes here basically with rubber asphalt. We also had 2 lanes for polymer sections. Basically, that means the polymer asphalt. Of course, polymer asphalt in general is a material called SBS type of polymer, which is more expensive than rubber. So basically, in this project, we are trying to see, well, if we can compare rubber versus polymer, if rubber materials can perform well, so with lower cost, so why not really just promote use more rubber instead of a polymer? All right, so normally we don't really use polymer unless really heavy traffic or maybe on special cases because polymer asphalt is quite expensive. All right, so I'm going to have one more poll here is what is the average daily traffic in Kent County project? I just showed you a minute ago. And so basically for this one, what's the traffic volume? So you can imagine
And there's three choices.
Go ahead.
The first choice is 5,500 items of traffic per day. So that would be cars, trucks, everything. The second choice is double that, or about double that, 10,500. And then the third choice is 16,500. And looks like people are choosing B, which is 10,500. Of course, we have no idea really. There were two lanes of traffic. Or you're counting both ways, right? Like
that has to be all the ways.
About out and back?
Yes.
Okay.
Because that's basically applied on the same road.
Okay. True. It's once out on one road and once back on the other road. Yeah.
Yeah, the 5 lanes you can see basically the outer 2 lanes basically use them often. The center lane normally for turning.
All right. Looks like the majority, 61% believe the answer is 10,500.
Okay. Well, really my answer here is basically what we counted, and also according to the prediction, and also of course the county did a really good job. They counted is 16,500. So amazing. It's really high traffic areas. That's the reason we spent quite some effort, did a lot of testing on this road before we place the material on the road. So basically, we spent quite some time observing, basically the materials design, and spent quite some time during the constructions, and a lot of testing post-construction. So the really high traffic volume, so 16,500, and there are pretty significant amount of truck traffic, because this is a road basically going to interstate highways. All right, thank you, folks. And my next thing basically talking about here is some of the lab work we did. One of the type of lab work basically I did here is we call the DCT testing, or called disc-shaped compaction testing. So you can see here is basically a sample is like a cylindrical sample, and we just cut a notch here and cut 2 holes on the 2 edge. So basically we are trying to stretch it, right? You stretch it if the material is tough. So basically you will spend a lot of energy to crack it. And of course, if the material is soft or brittle, it's easily you can crack it. So basically what we measure is the load versus the displacement. The energy underneath the curve will be calculated as the fracture energy. So if if a material is tougher, of course they need so basically you need more energy to crack it. So basically that means the area is larger. So for this project in Cumberland County, I just want to show this one. So the conventional asphalt has 467 joule per square meter of energy, but the rubber asphalt is 578, 579. So it's much better than the other one. And the more fascinating thing is going to be my next picture I want to show you. This is a project in Kalamazoo County. Remember, this one we had 18% of rubber in the asphalt, which is really high concentration. And for that one, you can see the green colors basically are the fracture energy for our designs. And on the first 2 bars are conventional asphalt. So the conventional asphalt, for example, the strength, the energy, the fracture energy only about 400. But we can, in our new design, we are on average about 1,200 or so. So basically, we can easily make that one about 3 times higher than the conventional asphalt. So basically, this is really good thing. So basically, that means the material is going to be really tough. So basically, anti-crack. So basically, I don't expect too much of fatigue cracking, or maybe low temperature cracking.
So that was at about room temperature, right? 24 degrees.
No, this is minus 24 degrees. Sorry for that.
Minus 24. Wow, that's impressive.
Yeah, because low temperature cracking basically happening in really freezing temperatures. In summertime, for example, you really don't see much cracks, but the wintertime is happening very often. And that's the reason we test really freezing temperatures. Very good question. Yeah, this is a minus. And another type of application we did with rubber is called chip seal. My very first chip seal attempt was in 2018. you can see in this in Kalamazoo here, we have a special distributor truck. This distributor truck has the heating element and agitation inside. So basically, normally you just have emulsions, right? Basically, but for our research, we have hot asphalt here. And then we have rubber being introduced through the auger to this truck. And then basically with a certain amount, for example, like I just mentioned, it was really high percentage. And then we blend it, right? Blend it, agitate with high temperature, right? Basically that so that we can, the asphalt and the rubber can work together and make a really uniform structure. And then with that, basically we distributed that hot asphalt to the road that you can see here on the left-hand side. So basically that is after the distribution of asphalt. So normally for this one, we use about a half gallon per square yard. That's pretty significant. So with that much of asphalt and with a lot of rubber inside, then on the top, we apply chips, which is small stones, and compact it. That's basically you make a new road. This road, of course, low cost, but potentially can be have very good longevities because of rubber applications. I'm going to show the next one is, so last year, we did basically with a different chip seal. This chip seal, we also use hot rubber, but we are not going to introduce that to this truck, right? You see this truck is basically, the asphalt liquid are coming from the plant. We basically produce this in the plant. You can see on the corner here, so basically this is a yard. We basically process the rubber, and the rubber will meet with asphalt, and then basically let it cure, and then basically put that in the distributor truck, and then send to the road. Right. So basically, this is how really basically they spray hot asphalt on the road. So basically about more than half a gallon per square yard being applied. You can see existing road condition is pretty bad, a lot of cracks. But this is basically how we are doing this type of project. And you can see this one actually is not smoke. All right, this is not smoke. You don't really smell too much, really. This is really steam because road structure is kind of cooler, and there's the asphalt in the come out basically pretty hot. So basically when they meet together, basically generate a lot of water vapors. And my next slide is basically showing you basically after the spraying, right? So basically this is the one, the hot rubber being applied on roads. So basically we are applying chips on the top. So basically after chips is ready, we are going to compact it to make a new road. So as I said, this is really low cost way to maintain an existing road. And about the chip seal, as you see, we did quite a bit of work, and we're not really only doing the research work in Michigan. We also did a project in for Minnesota. For example, these cores are all from Minnesota. Basically, we tested some of their chip seal work as well. But of course, all these chip seal are conventional chip seal, not the rubber chip seal as we discussed here. And I'm going to really briefly talk about some of the models we have, because I know most of the time you really would like to see what the university is doing. All right, doing the lab work. Of course, we always do lab work, and we also always like to see applications. And sometimes computer models is something sometimes very unique. There are a lot of insight we can get. For example, here, as you see this picture here earlier on, right? So basically, this is before the sample being tested, and on the bottom here, this is a sample being tested. You can see there's a big crack happening, right? Almost like if you stretch the sample, if you can crack it. Like -20 some degrees C, if you stretch it, I don't think any of you on audience really can crack it with your hand. Anyway, but really, we did was basically the model here. So the model basically used a certain model we call the discrete element models, which I used in my research career. You can see this basically the model, the overview. You can see the top view. And during the simulation, basically we apply force, right? On the, for this picture here is vertically. And we monitor how much cracks being generated, basically the length of the cracks being generated. So basically on the picture here, I said displacement. Basically everyone really see how much displacement generated in any directions, any locations. And also we can also find out what's the contact force. All right, I'm going to show you, for example, on the picture here, you can see one sample has rubber, the other no rubber. All right, so basically with there's no rubber, the asphalt sample really can only go through whatever amount of displacement. So basically that means crack quickly. On the right hand side, you can see the red color things going forward. Basically there are cracks. So basically this sample will allow you crack much more displacement until it's cracked. All right, so basically it's the failure. So basically that means there are some unique advantage when asphalt be introduced with some rubber. So basically on the right hand side, this one is the better one to use with rubber. So I'm going to show you next picture. And my next picture here basically showing the contact force chains. I'm going to really click this one. You can see during the simulation, I basically take it out, okay, because all the images gathered together is kind of hard to read. So basically I only separated all the contact force chains come out. You can see this one, remember the crack really happening, and then the contact force continuing to move towards the left. So basically crack the sample really quickly, right? Concentrate the force. But on the right hand side, because of its rubber, you can see the force has been redistributed to different locations. So that really means the sample will survive much better. So that's basically the differences between even same structure, exact same structure. The only difference here is basically introduction of new rubber materials inside. Right, this is some modern work, of course, and I like to show you. So basically, we have done quite a bit of field application work. You can see this map here is we have showing basically all the project we did until this year. You can see Keweenaw County was the project, the first one we did, and we did Kalamazoo, we did Dickinson County, then Kent County. So basically, we have a lot of other projects going on, and we're always really like to work with all our partners together. So basically, we can generate new knowledge and promote knowledge. And I'm going to introduce my my assistant Kobe. So Kobe has been here with me over 2 years. So he has helped me did quite a bit of research project. So Kobe, are you ready?
Yeah, yes, I'm ready. Hello everyone, I'm Kobe. I'd like to introduce some field performance testing work in the past 2 years. The first picture on the left shows that we measure the elastic modules on the subgrade. And also the second one shows that we measure the penetration depth of the subbase layers. And all the results is testing US 41 and it will be used for the pavement designs. And the third one is we take some field call after the construction in Kent counties, and we also evaluate the pavement performance based on the field call. And the last one is shows that Dr. Yu is operating the asphalt pavers on the road in 2021. Actually, the pandemic cannot stop us, and also cannot stop the construction of the recycle road in Michigan.
Can you imagine I drive this vehicle without license?
I was going to say, is that really you up there?
Yeah, let me continue. And we also have trained lots of undergraduate and graduate students in our labs. Here only shows the research assistant in our lab in the past 2 years. And we also very appreciate their contribution to our lab and to our research. And we also welcome more future engineers can join us and do more research work.
Great, thank you very much, Kobe. Yeah, these are just some of the assistants we have. We can find the pictures. We have a lot. We don't have their pictures, so basically we cannot really find put it here. I might have another poll. So basically here is what is the percentage of asphalt in the asphalt concrete materials? So you see on the top layer of asphalt, that's black color. I just want to know how much percentage you think there are. And the question, the answer is 20%, 5%, 50%. Looks like a lot of people right now picking 20%.
Well, and what's the rest of it? So there's asphalt binder, there's small rocks in there.
Yeah,
There's,
there are plenty of rocks.
and there's rubber from your tires.
Yeah, tire rubber. Yeah, the tire rubber is very small percentage. Normally, For example, for the project we did in Kalamazoo County, we had 18% of the rubber in the asphalt. So basically that means the asphalt, if the asphalt, for example, is 10%, 18% that means 1.8% of the entire asphalt mixtures, because the mixtures has a lot of stones. So for most of the asphalt mixtures, we have roughly 95% by weight are stones. Asphalt itself, there are only roughly 5%, at most 7%. For very special cases, for example, for Mackinac Bridge, one lane, well, one each direction is steel deck, the other basically is asphalt. That asphalt probably about 6% of asphalt. So you're not really going to use anything more than 20 or 50% of asphalt, which is going to be very flowable. When you walk on it, you probably will be worried if you are going to fall into sink. So yeah, right. Yeah. So basically 5% is probably our best answer here. Thank you folks for your taking care here. And plus the asphalt is most expensive part in all the materials. Let's see in asphalt and the stones. Stones, for example, let's see $15 a ton. Asphalt is right now probably about $600 or close to $700 a ton. It depends on the crude oil, and the price tag is increasing actually over the years. Last year was about $600. So that's basically aggregates, which is stones. Of course, it's way cheaper, but of course aggregates, high density. So basically, one big truck load, you can easily haul many tons, like 30 tons, 40 tons. So that's basically, 5% is for asphalt.
Very good.
All right.
So 5% was the answer.
Yep, 5% is the answer. That's correct. All right. So I'm going to move on as basically talking about. So basically, so far we talk about our overview of field experiments, and I showed you some work basically we did in Kewanee County, Kent County, Dickinson County. Of course, there are some other projects I did not show, and we showed some of them. Only one test we did in our laboratory, and which is the cracking testing. We also do quite a bit of a computer modeling work, and basically showing the fundamental properties of materials. And then basically Kobe talked about our workforce development and education. I'm going to briefly talk about some of the recognitions we have here. You can see here is basically a project we did in Dickinson County, and after that one we won the award from County Road Association of Michigan. And this project is, of course, we partner with Dickinson County Road Commission and also their biking association and a few others. So Eagle is our major sponsor. So basically, we had this road really opened. So basically, it's pretty good, good impact. And in the project we did in 2018, you can see we have really a lot of partners joined together to work on this project. And contractors, material suppliers, and Michigan Tech students and researchers, and of course road agents, road commissions from Kalamazoo County, and also with support from Eagle. So basically, with that, we ran the 2019 Project of the Year award, which comes from the American Public Works Association. And of course, this project is for the category of project spend less than $1 million, because for a lot of road projects, it's impossible you can spend anything like less than $1 million. But for most project we do, it's pretty much less than $1 million. So basically, this is a pretty nice achievements.
Congratulations.
Right, thank you, Janet. So there are a lot of opportunities. So basically, in terms of the applications of tire rubber or any other type of materials, there are a lot of things we can do. Materials innovations. So basically, there are a lot of things we can do to do better materials design. and of course, essentially also pavement design. So how really we can build strong pavements with good materials, and of course, we want to really look for any new materials we can potentially save from the landfills. For example, somehow like plastics and glass, roof shingles, of course, recycled asphalt materials, demolished materials. So basically for all those things, there are really good potential where you can recycle those things. So basically our near plan is also trying to move to do some work in the recycled plastics for roads, and of course glass as well. So we also realize that there are a lot of opportunities in workforce development. So we need to train a lot of engineers so that they know the basic concept, so that really we can do a better to develop materials from all those wasted materials. And of course, it's also essential for us to team with the industry and the government agencies. For example, we work with industry. So basically, how really we can recycle those materials, and we need whatever sizes, this whatever temperatures. So all those parameters we set together. So basically, then we can feed in the materials, and then with government agencies, basically, all about the specifications and potential fundings. So all those things are all should be lined up together so that we can do a successful project. And with that, of course, we have a lot of things to acknowledge. A lot of organizations, especially Eagle, DEQ, over the years, they have been our major sponsor, and MDOT has always been helping with us. So basically, they always provide whatever we need. And a lot of radio agencies, as you can see on this picture here, basically, we have a lot of agencies working with us. So basically, help us to bring research to the road, to practice. With that, I have my email address here and also Kobe's email address here. So if there are any questions, we'll be happy to answer by emails. Of course, I'm very happy to answer if there are any other questions in the Q&A.
We do. We've got lots of questions. So I will clear out some of these, but Kobe, do you want to go ahead and pick a question? So kind of starting from the top, and if you choose to answer it, just click answer live. So for example, I'm going to choose one right now. So Ward asks this, 30 mesh is 560 microns. I don't know if that's a question or a statement. I think it's a statement. So, because you said you had filtered things to 30 mesh. So that's particle size of 560 microns or smaller, right? Anybody know? So we're answering these out loud. So Kobe.
Yes, I think it's right.
All right, excellent.
Yeah.
All right, so now I'm going to click done on that one. And go ahead and Kobe, you pick the next question to read. Yeah.
Yeah. Okay, this one, air pollution when construction asphalt roadways. It's asked by Harry Jones.
All right, so click answer live.
Okay.
There you go. All right. So is there air pollution when constructing asphalt roadways?
I think really when we pave asphalt, it have some smells from the asphalt benders, but I think they all satisfy the requirement of the government. And okay,
it's a little smelly, I admit, but
yeah.
But it's not. It's a temporary thing, right? Right.
Yeah.
Dr. Yao?
Yeah, I can add a little bit on it. So basically, we did a project in Kiona County here. So that project, we actually get a 2 project. And one project basically when constructed road. The second project basically to measure all the emissions. We basically spent quite some effort to measure the emissions come from the asphalt plant directly, the exhaust system. So we measure what is the chemical compounds through those materials. We want to make sure those things are not really really bad to be released to the air. Of course, there are some chemical compound which is not desired. We don't really like to see it. And those are, so basically those materials essentially are all under the Eagle's requirements, so air quality requirements. So basically, they are okay. Of course, if you really want to say I'm enjoying to breathe those things, probably you don't have to, which is not really good for you anyway. Sometimes the odor you smell, maybe those kind of sulfur type of compounds, those are actually not going to be really bad, but of course, all those things are regulated. So we essentially, especially through our research, and the Eagle were able to lift the bans for most of the plant. They can basically start their paving or operations, because our research found out the compounds is from the plant are really small compared with specifications. So specifications, for example, said 20, our results only 2. So
No,
it's
that's good.
really, yeah, so really small.
All right, so Kobe, for that question that you said, you can click done now,
Okay.
and then go ahead and read another question.
Is noise level measures? Okay, actually we measure almost all the rubber modified asphalt pavement. We have measured the noise level, and also for the Dickinson, when I started here, we have measured the pavement noise in Kalamazoo County's pavement and the Dickinson County pavement and the Kent County pavement. And based on my study and the database there, generally the rubber modified asphalt pavement is lower than the conventional and polymer.
So the sounds that the cars make when driving down the road, it's quieter on a.
Yes, absolutely.
Yeah,
nice.
Correct.
Excellent.
Yeah, roughly I remember it's about 2 to 3 decibel points. So that's pretty significant.
Okay, let me choose another one.
There's a question, which road in Kalamazoo?
Oh.
I can answer this one. So this is basically in the called West Road or W Road in Kalamazoo. So it's near the Schoolcraft. What's that? Is a district.
Okay.
Yes, Schoolcraft. So yeah, it's basically their speed limit is I remember 55 or 50. So basically about that range. So pretty busy road, parallel to the train.
Okay. There's so many questions. I'm relying on you guys to pick them.
Sure. And okay, I can answer one question from Bob. What is the binder? So we sometimes call binder, basically means because it's liquid asphalt. So liquid asphalt, a lot of times we call it asphalt binder, because really we think it's asphalt basically is a glue, basically glue all the stones together. That's the reason we call that is a binder.
Okay. So there's a lot of people saying thank you, really interesting talk, and then we have somebody pointing out that back in the old days when they went to school here, they used to be able to see copper in the road.
Yeah, that's right, Janet. Actually, we did see some coppers in our stones too. When we compact some samples, when we cut it, and we found, oh, nice copper. So basically, we saw those things. I can help answer another question here. The question is about the sugar. All right, sugar, 250 to 500 microns, and so asphalt, the ground tire rubber, which is a little bigger than that. That's right, about 600 microns. So that's about right. So 30 mesh, roughly about that, about 600. Kobe, you can answer one more if you want.
Okay.
Well, there's a question about cold weather from our Alaskan. How do these roadways, how do they hold up in the really cold weather?
Okay, well, I can answer this question. I can give a try. Minus 30 degrees Fahrenheit, it's really cold. That's really cold. So normally what we do in asphalt industry, we normally have a so-called a performance grade. So for example, in Houghton, our coldest temperature is minus 34 degrees Celsius. Kobe, you convert to degrees Fahrenheit to see what is that.
Okay.
So basically, that's basically for that kind of a weather here in Houghton, we use PG something minus 34. So basically, the minus 34 basically means the asphalt will survive at this cold climate conditions. So roughly, I think it's minus 30 degrees Fahrenheit, probably
34. Minus 34 Celsius. Yeah.
Okay, so basically, minus 30 degrees Fahrenheit is same like Houghton's cold weather. So minus 34 asphalt will work. That's basically the coldest that we see in Houghton's history. And I know sometimes in some areas in Alaska, the coldest temperature need to be using asphalt minus 46 degrees C. In asphalt industry, we like to use degrees C, but it's really close, in Fahrenheit at that stage. So in some areas, basically you have to use minus 46, but sometimes there's not those kind of asphalt on the market. So basically because the crude oil, where it's come from, and also how you really make the asphalt. So sometimes the asphalt really basically cannot reach that standard. Basically for that kind of weather, just let it crack.
Because build a snow road, right?
Yeah, because if you already have that kind of cold climate, really you probably are not going to have really super heavy traffic. Probably. So
well, and
of course
how
there are, go ahead, Jenny.
well, so what about the opposite, right? Now remember this person went from Hawaii to Alaska. So
Yeah.
how do these kinds of, with tire in the road, do they get sticky at very hot temperatures?
That's a very good question. That's a very good question. For example, if you're living in a place, for example, in some hot climate areas, when the roads summertime, the asphalt tend to going out, so kind of you feel kind of sticky. That's because one is basically because the asphalt, maybe the asphalt content is too high, air voids too little. That's a potential possible. So those basically let your asphalt going out. You're not supposed to feel it's sticky, but yes, it will be sticky, but you're not supposed to glue your feet, But of course, for low temperature, we have a lot of other ways to deal with it. So basically, asphalt is one thing we can do, but of course, there are many other factors we have to consider.
So is there any difference in road damage between a loaded up semi tractor trailer and a car?
Oh, okay. I can help answer this one also. Absolutely. Those trucks, those will cause more damage, basically to the roads than autos. Like autos, like you and I drive those small sedans, for example. Every like 2,000, 3,000 of those cars is equivalent to one 18 Cape standard truck. If you have the heavy loaded like 18 wheelers, those are probably is equivalent to like 30, 40 standard truck. So basically you can imagine that causes much more damage to the roads. That's the reason a lot of times the those vehicles will pay more on the gasoline, right? Because they use more gas or diesels. But of course, sometimes the tolls will be higher too, but still, I think in that sense, I feel like we pay too much tolls compared with the truckers.
Kobe, do you see a question you'd like to answer?
Yeah. I see does this only have implications in cold weather regions, or does it still hold up well in warmer regions, southern US? And actually, based on my lab testing for the Kent material, the rubber modified material compared with the conventional asphalt, not only the low temperature performance, but also the high temperature rotting performance also shows better than the conventional asphalt. So I think yes, it also not only improves the low temperature performance, but also improves the high temperature performance.
Yeah, I can maybe add one more thing here. So basically for the for rubber materials application, in general in US, in northern climate areas, we tend to be afraid to use tires, rubber. In the southern climate, they sound like a little bit more open. for example, in Florida, Arizona, they use a little bit more rubber than northern climate. But Michigan is the best one dealing with rubber in northern climate.
Michigan's
So far, I
willing
think
to
we
do
built,
this.
I would say, probably 80 projects over the
Nice.
years. Yeah, a lot more than other states.
Well, I mean, it doesn't seem very risky, right? Because if you're doing tests on them and you have controls, it's good to have data. And
Yeah, that's right. Well, there's one question asking about if the asphalt with tire rubber can be recycled in the same way as regular asphalt. I think this question, I think for this one, so far, because especially in Michigan, so our earliest project is only like 6 years old. We have not recycled those materials. We are waiting for at least another 10 years to see what happens. But in research wise, we can do it. We basically can recycle the same way like we did for regular asphalt. So basically, because the rubber content in those materials are basically pretty small, really is for the entire recycled materials, you really only less than 2% of rubber inside. So that should not really cause a bigger deal. But of course, we are doing some research work to validate what we are thinking.
well, here's a question from Mark. It's about studded tires. Have you taken a look at how well these recycled materials stand up to the damage from studded tires?
We have not really tested anything about studded tires. In Michigan, we probably don't use that studded tires here. I think we are doing basically in our research work, basically we are caring about if the truck has a dual tire or single tire on the back. The bigger truck, for example, like 18-wheelers, if on the back, for example, they have a single tire versus dual together, so basically they are going to cause some different of damage on the roads. So that is something we got a project right now working with the Michigan Department of Transportation to deal with that. So our initial finding is, yes, there will be some more of a damage with single tires, because single tires, you can imagine, you're going to have a little less contact areas from tire to the roads. So basically the pressure is more, so it's potentially causing more damage.
Yeah.
But that is ongoing research.
Kobe, here's a question for you.
Okay.
How do you take the core samples, and what do you do with the hole in the road that you leave behind?
Actually, we have the specific equipment from the road commissions. When we discuss with the contractor, they will help us, and we work together to get the core from the field, and also we will drive the core to the lab and do the testing.
And
Actually,
then
and also we have developed some equipment in our lab, but right now we don't need it.
well, and so do they patch the hole? They just shove some.
Yes,
More
after they take the core, and they have we still actually it's only we still have lots of hot loose material. We can directly refill it and pack it.
Okay, I was wondering about that.
And I
Well,
found one more
go ahead.
question. Okay.
Go ahead. Yeah, go ahead.
The use of tire in the asphalt improve the pavement response to frozen soil recycles, and we could really use something that will reduce potholes in Michigan. And actually, based on my testing results in Kent County, and we compare the conventional rubber modified asphalt pavement and polymer modified asphalt pavement. Actually, the rubber and the polymers both performs better with the frozen soil, and also rubber material will be cheaper than the polymers, and they have similar performance. So I think this answer is yes. Actually, rubber will improve the pavement performance compared with the conventional asphalt pavement.
Good to know. There's so many questions. This always happens. So now we have 39 open questions. And it's 7 o'clock. And so I'm the mean person who says, all right, everybody else who still has a question, I'm going to ask you to please email Zhanping, and maybe Zhanping, you can add your email to the chat so
Sure.
people can reach you.
Yeah, it's this year now.
Yeah. I think
Good.
Sue already put the email there.
Great. Thanks for doing that. And so I want to kind of, I really feel terrible wrapping it up at 7 o'clock with 41 unanswered questions. So we're going to take 2 more questions because I feel so bad. Zhanping, you pick one, and then Kobe, you pick another one, and then I'm going to thank everybody.
Okay. All right. One question is, what is eagle? Eagle is basically I mentioned the eagle. Sorry, I did not really mention that one. Eagle means Michigan's Department of Environment, Great Lakes, and Energy. So basically, the government agency we call eagle. Too bad I did not explain that one better earlier on.
All right. Kobe, last question.
Okay, will you develop asphalt life inspection models to predict asphalt pavement road life? Actually, we did lots of lab testing in our lab now, and the rubber modified asphalt mixture performs better than the conventional. So if in the future, maybe we can considering to consider predict the real asphalt road life.
Nice. I have so many questions in my head that I want to ask, but I want to definitely just take a moment to thank both of you for spending your evening with us and for sharing your knowledge on Husky Bites. I love the title of this talk, Where the Rubber Meets the Road, and we can see that this is an outstanding set of projects that Dr. Yu has been working on across his career, involving recycling material that would otherwise go to waste to make actually heavily improved roadways. And so it was wonderful to have you both here with us this evening. And I want to thank everyone for joining us. Join us next week. We're going to be hearing from faculty emerita, Martha, who is she's one of our beloved faculty members in electrical and computer engineering. And so we'll see you next week, everybody. Thank you.
Thank you.
Thank you.